Hi and welcome to Math Foundations 20 example 2 for section 7.4. So we're still looking at factored form here. So we want to sketch the graph of the quadratic function f of x equals negative 3x squared plus 6x minus 3. So again, right off the bat here, we know it's going to open down and our y-intercept, right, is negative 3. Okay, so that's a good stuff to note. Alright, so using factored form here, we want to factor that. So we have f of x equals that, and we're looking for a GCF. Well, all of those are divisible by 3. So we want to factor a negative 3 out. So what if there's a negative in front of our x squared term, we want to factor out that negative. So we have negative 3 bracket x squared. Then that changes that to a minus 2x and that to a plus 1. Okay, and then the next step, right, we've got the negative 3, and then looking at this, right, 3 terms, we're looking at sum and product, so we're looking for a sum of negative 2, product of 1. The numbers that do that, negative 1 and negative 1, so we get x take away 1, x take away 1. Right, we could condense that into f of x equals to negative 3 bracket x take away 1 all squared. Okay, so if you see a function written like that, that's because both of those factors are the same. Okay, so the reason we use factored form is to get our x-intercepts. So in this case, our x-intercepts, define that, we're going to take this one factor, we go x minus 1 equals 0, solve that for x, we get x equals positive 1. Okay, is there another factor here? Well, remember from the step above we had a second one of those, right? If we did that a second time, we'd get the exact same intercept. So what does that tell us? Well, if the graph has the same x-intercept twice, it can't actually be two x-intercepts. It just means that the graph, right, is going to just touch the x-intercept once. There's only going to be the one intercept, or the one 0 or root. Okay, so we've got one x-intercept, and so what does that tell us in terms of our axis of symmetry? Well, if we just look at that little sketch I just did, right, if our graph just touches the x-axis at one point, well, that point there, right, that point has to be our vertex. Okay, so that tells us our axis of symmetry is also x equals 1, and our vertex, well, it's going to be 1, 0, because it's right there on the x-axis. Okay, if you're not sure about the 0, remember we could sub that into our function. So where did that come from? Well, f of 1 equals negative 3 bracket x. Oh, sorry, not x. That's where we put the 1 in. 1 minus 1 squared. Simplify that. 3, negative 3 times 0 squared. Right, it's just going to be 0. Okay, but you don't need to go through that work if you can realize that, hey, that's my vertex. Where those two x-intercepts are the same, that's my vertex. Okay, so now we want to try and graph this. It's going to be a little bit different because we don't have quite as much information. But let's check if we have enough information to do a graph. Okay, so just getting my axes on here quickly. My x, my y. The numbers I'm looking at, things like 1 and 0, and my y-intercept is negative 3. Right, so I don't need to do anything crazy with my scale. So I'm just going to, each box will be a 1. Okay. So going to graph this, first thing I want to put on my graph is my vertex. My vertex is the point 1, 0. So that's there. Label that. Okay, my axis of symmetry, right, goes through that. So I'm going to put that onto my graph. So my axis of symmetry is x equals 1. What else do we know? Well, we also have a y-intercept of -3. So this here is my y-intercept. So that's the point 0, -3. And right now we don't have anything else. But based on the fact that this is symmetrical, right, since we know that we have a point right here, that also tells us that 1 to the other side of the line at that same height has a point. So we can put another point there. Okay, and then we could discuss whether or not that's enough to draw the graph with. But I think for our purposes, that's enough information to draw a graph. So we go from our vertex and through there, vertex through there, and we get our parabola. Okay, and last step is just put our original equation onto that graph. So f of x equals -3x squared plus 6x, take away 3. Okay, so that is our graph for this. Let's look at what these other questions ask. So how is the graph different from that in example 1? So if you just looked at example 1, remember in that one we had x-intercepts of -6 and -1. In this case we just have the 1. So that would be my main difference, right, is the fact that it has one x-intercept. Okay, other things that would be different, this one, right, this one opens down. Those would kind of be the main things. Okay, and then the last question there, C, how are the x-intercepts related to the vertex on this graph? Well, that was the information that we used. Since we had the same x-intercept both times, we only had one x-intercept. So since we had only one x-intercept, it's actually our vertex. So since we had only one x-intercept, the vertex is at that point. And that's an important thing to just keep in mind. Okay, so that takes care of example 2 there. So there again is our graph. We factored it, found that we just had one x-intercept of x equals -1. That's also our axis of symmetry and also our vertex. Okay, thanks.